Picture a far future evening when the blue planet we call home is no longer safe. Maybe it's a billion years from now, when the sun swells and scorches the oceans. Maybe it's far sooner, after centuries of climate breakdown, asteroid strikes, or an engineered catastrophe. Whatever the reason, Earth, once the cradle of life, has crossed a threshold. Staying means extinction. If humanity hopes to survive, we'll need to leave. Where could we possibly go when our own world finally fails? Before we dream of distant stars, the logical first refuge is our own solar system. The moon is the closest option, only 3 days away. Its lack of atmosphere and its harsh radiation make it a challenging home, but as a way station it's ideal. We could build underground cities or vast domes, using lunar ice at the poles for water and fuel. The moon might serve as the launchpad for deeper exploration, a training ground for generations born off Earth. Mars is the next obvious candidate. It already has day-night cycles similar to Earth's polar ice caps, and resources we could mine. Colonies would need pressurized habitats and protection from radiation, but with technology, greenhouses, fusion power, terraforming over millennia, Mars could sustain permanent human settlements. In fact, if Earth became uninhabitable gradually, Mars might be the first true second home. Asteroids and the moons of the gas giants offer another path. Places like Europa or Enceladus hide global oceans beneath thick ice, and while these worlds are bitterly cold, they hold water and the chemical ingredients for life. We might carve out rotating habitats inside asteroids or build enormous O'Neill cylinders, spinning space stations with artificial gravity and self-contained ecosystems. But the Sun itself is mortal. In roughly 5 billion years it will become a red giant, boiling away the inner planets. Long before that, rising luminosity will make Earth and Mars unlivable. To endure on cosmic timescales, we'd have to leave the solar system entirely. The closest targets are in the Alpha Centauri system, just over 4 light-years away. Astronomers have already spotted Proxima Centauri b, a roughly Earth-sized planet in the star's habitable zone. We don't yet know whether it has an atmosphere or liquid water, but it's the nearest candidate for interstellar settlement. Traveling there demands propulsion far beyond today's rockets. Concepts like fusion drives, antimatter engines, or light sailcraft pushed by giant lasers could shorten the trip to a few decades. Generation ships, vast vessels where people live and die during the journey, may carry entire cultures through the void. Farther out, the galaxy is rich with possibilities. Thousands of confirmed exoplanets, some Earth-like, some ocean worlds, some orbiting quiet, long-lived stars that could outlast the Sun by trillions of years. If we can cross interstellar space, humanity might scatter across many star systems, each colony evolving its own customs, languages, and even biology. Perhaps the most practical refuge isn't a planet at all. We may build habitats of our own design, independent of natural worlds. Engineers and visionaries already imagine rotating space megastructures, O'Neill cylinders, Bernal spheres, or ring-shaped stations miles wide that spin to create gravity. These habitats could orbit stars, drift between them, or travel as slow interstellar arcs. With closed-loop life support and advanced energy sources, fusion, matter-antimatter, or energy harvested from stars, they could last for millions of years. Such constructs free us from planetary limits. We would bring our own oceans and forests, control our climate, and move wherever we choose. In this vision, humanity's future isn't tied to a single rock but to countless floating worlds of our own making. Even stars burn out. Over unimaginable eons, galaxies collide, black holes dominate, and the universe itself cools toward darkness. To survive that far future, our descendants might need technologies we can scarcely picture today, tapping the power of black holes, migrating from galaxy to galaxy, or transferring consciousness into forms of matter and energy that can endure near absolute zero. Perhaps we become a digital species, living in vast computational realms powered by the faint trickle of starlight or the energy of rotating black holes. Perhaps we learn to manipulate spacetime itself, opening gateways to new universes. Which route we take, Mars settlements, interstellar voyages, artificial habitats, depends on how and when Earth becomes uninhabitable. A slow-warming sun gives us hundreds of millions of years to adapt. A sudden catastrophe, like a rogue asteroid or engineered pandemic, would force quicker moves. First to the Moon or Mars, then outward as technology matures. All of these futures share a common requirement: cooperation and foresight. Building off-world cities, generation ships, or megastructures demands resources, knowledge, and unity on a scale we've never achieved. Whether we can rise to that challenge will decide if humanity ends with Earth or outlives our planet by billions of years. If one day our blue world can no longer cradle us, we won't simply vanish. We'll carry our oceans in tanks, our skies in domes, and our stories in memory chips, spreading across the stars. Earth is our birthplace, but it doesn't have to be our grave. Thanks for watching this journey into the unknown. If you loved imagining the impossible, hit like and subscribe for more mind-bending what-if adventures. And tell me in the comments, what's the next wild question we should explore? Your idea might be our next video.